Hey everyone, welcome back to Simply Sports Science. Today we're going to continue with our A to Z of sports science and PE terminology and look at antagonistic pairs. This is a topic that comes up almost every year in examinations, and as such it's important to have a good understanding of what it is, how it works, and some key examples that you can add into your answers. Obviously, the higher the level of the course you're taking, the more in-depth your answers will need to be, but critically, the knowledge and information you need to demonstrate is quite similar across all levels. So have you ever wondered how your body moves so smoothly, allowing you to lift weights, run, or shoot a basketball with precision? The answer lies in something called antagonistic muscle pairs. Antagonistic muscles are pairs of muscles that work against each other to create movement. When one muscle contracts or shortens, the other relaxes or lengthens. This coordinated action allows our joints to move smoothly and effectively. So how does this work? Well, the agonist or prime mover is the muscle that contracts to cause the movement. The antagonist is the muscle that relaxes to allow the movement to happen. Let's look at an example with a bicep curl at the elbow. When you curl your arm up, the bicep contracts, making that the agonist. At the same time, the tricep relaxes, acting as the antagonist. When the movement is reversed and you straighten your arm, the roles simply reverse. The tricep now contracts, becoming the agonist, and the bicep relaxes, becoming the antagonist. This dynamic partnership is found throughout your body. Some key examples of antagonistic pairs that you could use in your answers include the bicep and tricep, which controls movement at the elbow, the quadriceps and hamstrings, which control movement at the knee, the tibialis anterior and gastrocnemius, which control movement at the ankle, specifically dorsiflexion and plantar flexion, and the hip flexors and glutes, which control movement at the hip. These muscle pairs are vital for effective performance in sport. Their importance stems from several key functions. They control the speed of movement. They allow for precision, which is crucial in actions like a basketball shot. They contribute to stability around joints, helping to reduce the risk of injury. And they ensure fluid movement, preventing jerky or uncontrolled action, important to sports performance. To summarize, antagonistic pairs are critical because they enable us to move in two directions at each joint, ensuring balance, control, and effective performance in sport and physical activity. When you're answering questions about antagonistic muscles and pairs, the exam style and depth of your response will depend on your level of study. At GCSE PE, questions are usually short and straightforward. You might be asked to identify the agonist and antagonistic at the elbow during a bicep curl. To answer, you just need to state the muscles involved. If, for example, the bicep is the agonist and the tricep is the antagonist. At A-level, questions require more depth and explanation. For example, you might be asked to explain how the antagonist muscle action controls movement at the knee when kicking a football. And here you should identify the muscles, describe their roles, and explain how they work together to produce controlled movement. And at IB sports science level, the style is more scientific and analytical, and with all IB questions could include a number of different topics or subjects within a single question. A question might ask you to analyze the role of antagonistic muscle pairs in sporting performance using examples from more than one joint. Here you would need to use accurate anatomical terminology, giving multiple sporting examples, and show a clear understanding of how antagonistic pairs contribute to movement, but not do it in isolation. So the key differences at GCSE focus on identification, at A-level on explanation with applied examples, and at IB on analysis and evaluation using precise terminology and multiple contexts. So that is a brief overview of antagonistic pairs. Come back next time for more A to Z topics from Simply Sports Science. And if you've used this video, please help us grow by liking, subscribing, and sharing our content with your friends and fellow students. See you next time.